as the eagle-eyed youngster will know, this is a National 5 Numeracy practice booklet. I'm going to go through a few of the practice papers, which should be excellent preparation for your National 5 Numeracy. There's lots of really good work on the National 5 maths.co.uk website, so if you're looking for any materials to work on, check that out. But these papers should be absolutely sufficient for your National 5 Numeracy. So let's have a start then. Where's my pen? There we go. Okay, so first question. A house costs £96,000 and it is appreciated by 1.6%. Calculate the value of the house after 4 years. It's very simple. This is our equation, which is the amount multiplied by 1 plus or minus the percent over 100 to the power of n. I'm actually just going to rewrite this slightly neater, but that's the equation that we're going to use. So it's 1 plus or minus the percentage divided by 100. So our amount in this case is going to be £96,000. I'm going to multiply by 1 plus because we're appreciating, and it's 1.6 divided by 100, that's the percentage, to the power of 4. You can just go ahead and put that straight into your calculator. I'm going to put one more line though that says 96 times, and that's going to be 1.016 to the power of 4. So if you did this bit inside the bracket, this is what you'd end up with. And that's the reason I like having this as a formula, because sometimes people see 1.6 and they put their decimal multiplier as 1.16. This ensures that you always have the correct decimal multiplier. So, if you're comfortable with the decimals, go straight to this point. I would go straight to that point personally. But I think if you want to just make sure you get this absolutely right, remember this equation, and then it's just a straight substitution. So 96,000 multiplied by bracket 1.016, and that's to the power of 4. And the to the power of button probably looks like this on your calculator. So I've ended up with 102,293. I'll just do 2 decimal places just now. So that's I'll just write a few decimal places. Okay. So that's my final answer unrounded, and it's to be to 3 significant figures. So there's 1, 2, 3 significant figures. So the number cuts off here, and at that point, I would say, well, 102, 2 stays the same because this number is 5 or less, and then that's going to be 0, 0, 0, and that's the end of it. If I put 0.00, that would be wrong because the numbers after the decimal would be considered significant. So just make sure you get 3 significant figures and then zeros and nothing after the decimal. So very straightforward question. That does come up all the time. All these questions are very relevant actually. There's not many questions that are just here and don't come up. But remember this equation, 1 plus or minus the percentage over 100 to the power of n. And all this is doing, this bit in the bracket, is giving us our decimal multiplier, which we then do to the power of, because we've got a compound interest. Every year we're increasing by 1.6. Next one. Now we've got fractions. So I'll just put question 1 over here. I'm going to run out of space quite quickly, I think. Question 2. So then we've got fractions. 3 friends share a pizza. Steve eats 2/5. Jake eats a quarter. What fraction did Jody eat? So Jody's eating the leftovers of the pizza. So we've got a whole pizza, and we're going to take away 2/5, and then we're going to take away a quarter. So that's effectively what we've got. So what we're wanting to do really is do 1 take away 2/5 plus a quarter. Think on it that way. This is the whole pizza. I'm going to take away these bits that have been eaten. And how do I add fractions which do not have the same denominator? Well, I have to make a common denominator by using smile and a cross. So a smile just means I'm going to multiply the 5 and the 4. So I should really put my equal signs there. Apologies. It's quite late. So there's 1 takeaway. And I'm going to do 20 and 20, because 5 times 4 is 20. 4 times the 2, this is the cross, gives me 8, and then 5 times the 1 gives me 5. So that means I've got 1 take away 13 20ths. So how can I rewrite 1 in terms of 20ths? Because right now I can't really do much with that sum. I'm going to rewrite that as 20 over 20. I could have rewritten 1 as 10 over 10, 15 over 15. I want it in 20th, so I can now do this meaningful calculation. 20 take away 13 means I've got 7 20ths left. So there's two main bits to this calculation. There's putting the two fractions together with your smile on across, and then doing 1 take away that number. And the 1 we have to change into a fraction with the same denominator. So 1 becomes 20 over 20. Next. A car park holds, so that's the next one. So that's us done percentage and fractions. The next one is looking at probability. So we've got a car park that holds 480 cars when it's full. And the probability of a car in the car park being silver is this. And on Friday morning, we found that there was this many silver cars. Is this more or less than expected? Okay, so the first thing I would do here is I would say, well, I've got 480 cars. Let's times that by the probability to see what my expected outcome is. So we take the number, multiply by the probability to give an expected outcome. So 480 times 0.375, that means 180. And I'm just going to put a little bit of words above that. So I'll write the total, multiply by the probability, and that's equal to the expected. Maybe a good way of thinking about it. So I expect 180. What I actually get is 164. So the actual is equal to 164. Now that number is less than expected. We expected 180, we got 164. So less than expected. And that's your thing. So 2 parts of the question. Work out what you would expect to get. We expect 180 cars. What did we actually have? Well, we actually had 164. That's less than what we expected because we expected 180. Simple. And I do get them confused sometimes. You've got to take your time. It's easy to work this number out and all the rest of it. So we actually had 164, which is less than 180. Readings. I'm going to zoom in for this one. Most important thing with the readings is to work out what your scale is. So you can see here we've gone from 20 to 25, and that's in increments of 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we've got the big one here for the 5. So we've got 10 increments. 10 increments. And that is equal to 5 kilograms. So what does 1 increment equal? That's going to be 0.5 kilograms. Okay, I'll finish writing the word there. So what I've done here is I've divided 10 by 1. So I divided 10 by 10 to get 1. So I have to divide 5 by 10 to get 0.5. So the increments are going up by 0.5. If the increments went up in ones, that would go from 20 to 30. But it only goes up to 5. So each time it goes up by 0.5. Then you've got to decide where is your pointer pointing. It seems to be pointing to this one here. So that's 1, 2, 3 increments in. So if that's 3 increments in, that's 3 times 0.5. So 3 times 0.5 is equal to 1.5. And if I add that to the original 20, I'm pointing to 21.5 kilograms. And we can just check that. We could say if that's 20, that's 20.5, 21, 21.5, 22, 22.5, 23, 23.5, 24, 24.5, and then 25. So you just double check that your increment makes sense as well. Next one. Emails. On here we've got another scale. We've got 140 going up to 160. So right in the middle here, it'd be safe to assume that's 150, bang in the middle. And then how many increments between 140 and 50? Well, it's quite hard to see, but this looks like 10. Again, we've got the longer one being the 5. So we're somewhere between 145 and 150. It's quite hard to see the quality here, but I'd say that's 147 or 148. So 147 or 148. And if you can do your units, that's excellent. This looks like it's in pounds, actually. If you look here, capacity up to pounds. So if you can do that, brilliant. But that's a bit of a harder one than this one, I'd say, because it's not clear. So in the marking scheme, would say 147 or 148 would be fine. It looks like it's actually bang in the middle, 147.5 if you actually look. Okay. Excellent, there's a little bit on scales. And the last little bit on graphs, this comes up quite a lot. So explain what the graph tells about the following people. So we've got heights and weights. This is a BMI graph. This is how we like to determine health for some reason, even though it's not exactly right. If you're a very small person and very muscular, your BMI is way off the chart. But this is what we've got. So yeah, Jamie's 5'10" and weighs 13 stone. So where's 13 stone? There's 12, there's 14, so 13 is going to be in the middle. So I could draw a dotted line up to say there's 13 stone. And where does that meet 5'10"? There's 4'10", there's 5'2", 4, 6, 8, there's the 10 there. So I'll draw another line. And I just want to see where these meet. Okay, so they meet right here. And which zone is that in? These colours are actually quite rubbish, but let's call this shade 1, 2, 3, and 4. And that's shade 1, 2, 3, and 4. So I'd say that's okay. He's in the okay range. But I think in other tests that I've seen, it's much clearer. Because actually I'm kind of looking going, was that shade, is that shade? But if I start from this side, I know that's obese. Sorry, clinically obese, overweight, and then okay. So shade 4. 1, 2, 3, 4. 1, 2, 3, 4. And the next person's 5'6" and 14 stone. So I'll just in a different colour. There's 14 stone. I'll just draw that up all the way. And they're 5'6". They're quite short, and a bit heavier, a lot shorter, a bit heavier. So they're in this zone. I'm going to call that zone 3. So they're in the overweight zone. Probably very close to my own zone. Overweight. So all you're doing is drawing a line from both of your bits of data and seeing where it meets. Ratios. So mortar is made of cement, sand and water in this ratio. If 80 kilograms of cement is used, how much sand and water is used? The first thing I always do with these is I would write that I've got cement, I've got sand, and I've got water. The ratio is 1, 2, and 4. So that's me got pretty much everything out of that first line into my calculation. I know I've got 80 kilograms of cement. So the cement has gone from 1 to 80. How did I get from 1 to 80? Well, I multiplied by 80. So I need to multiply all the other ratios by 80. So 2 times 80, 160, and 4 times 80, 816, 24, 32, and if I want to be perfect, I could use kilograms as well. Keep my units in there. Okay, so this is how much sand, and this is how much water. Excellent. Another question, an alloy consists of copper, zinc, and tin. So same thing, we'll say copper, zinc, and tin. And that's in a ratio of 2, 3, and 5. Find the amount of each metal in a 75 kilogram of alloy. So this time it's given us the total amount of the alloy, in the same way that I can add this up and work out the total amount of mortar I've got. So in this question, what I need to do is work out the total share. So I'm going to say 5 plus 3 plus 2 is 10. Okay, so that's actually 10. So then I want to get from 10 to 75. So I want this total at the end to be 75. So how have I got from 10 to 75? I've had to multiply everything by 7.5. So 7.5 times 2, that's 15. 7.5 times 3. It's a bit late, so I'm just going to double check that on my calculator. Long day at the office. 22.5 and 5 times 7.5. That's 37.5. Apologies for the mess there. I'll just double check I've done that right. If I say 37.5 plus 22.5 plus 15, it does indeed add up to 75. So that time we knew the total. So we had to total up the share and then work out how did I get from this total shares to the final total shares. So I was timesing by 7.5 each time. And that keeps everything in balance. 2 times 7.5, 3 times 7.5, 5 times 7.5. And then you finish the question by saying, 15 grams of copper, 22.5. Don't forget your units. But that's your two different types where you would just directly multiply each one because you've got cement coming from 1 to 80, so you times them all by 80. But in this last one, the total amount at the end. So you need to work out your total shares and see what your ratio is. And let's just do one quick question. The pie chart represents the choices made from our menu. If 24 people chose pork, how many chose the beef dish? So there's pork. So what I can say from this is that 40 degrees is equal to 24 people. So I'm going to work out what 1 degree equates to. So how do I get from 40 to 1? Well, I have to divide by 40. So I'm going to do the same to the other side of the equation. I'm going to say 24 divided by 40, and that gives me 0.6. So for every degree, that equals 0.6 people. And it's asking me how many people chose beef. Well, beef has got 150 degrees. So then how do I get from 1 to 150? Well, then times 0.6 by 150, and that gives me 90 people. Simple as that. So equate your degrees to the number of people and go for it. I'll stop there and I'll carry on with the rest of the paper on the next video. So I hope that was a useful introduction just to get you thinking. Covered a few good topics there. A bit of compound percentages, a little bit of fraction work, probability, reading the graphs, which is very straightforward. Again, reading graphs, bit of pie charts and ratio. So nothing too strenuous. I'd say the next bit's probably a bit harder.